Okay, this is the first lesson of our Unit 2, and this is on basically all of this really is just an application of the distributive property. So we're going to look at expanding a binomial times a binomial times a trinomial, or even a trinomial times a trinomial. We need to make sure we understand what like terms are and how we combine them. And the key is making sure that we understand that like terms have to have the same base and the same exponent. So if we look at this example right here, you can see that we're shown that we should know that 5 squared is 25. We should also know that 3 plus 5 is the same as 5. But when we write this, you see that just squaring the 3 and the 2, which gives you 9 and 4 equals 13, is not a true statement. We need to realize that this means that, which would be 9 plus 6 plus 6 plus 4. 15 plus 10 is 25. So you have these notes, so you should complete all these examples as I do. So for the first example, expand each of the following. And this is why I say it's really just an example of the distributive property, because we're just distributing x to everything in the second binomial, then 2 to everything in the second binomial. Or multiplying the first terms, the outers, the inners, and the last, and that's where that word FOIL comes from. So FOIL is just a way for us to remember how we should actually complete this multiplication. So the result here would be x squared minus 3x plus 2x minus 6. Then you need to finish this by combining any like terms. These are like terms. They have the same variable, same exponent of 1. So we just combine the coefficients of negative 3 and 2, which results in a minus 1. And of course, we do not need to write that 1. It should be understood. Whenever we don't write a coefficient, it's understood to be a 1. So anytime we see something like this, think of it as that. Remember from the example we saw in the beginning, it's not equal to this. And you'll see why. X times x is x squared. That will give us a negative 5x, or a minus 5x. Another minus 5x. And that'll give us a plus 25. We combine our like terms, and we get x squared minus 10x plus 25. Now I'd like you guys to pause and try C and D. Your answer for C, you should have this. For D, you should have realized that you're actually multiplying x plus 2 times itself 3 times because of the exponent of 3, the third power. So to do that, we're going to just take 2 of them, which will result in x squared plus 4x plus 4. Then we still have that other x plus 2. And I'm just going to write that in front. It doesn't matter. But I need to realize that this is now going to get multiplied, or really just have to distribute now x to everything in this. This is a binomial because it has 2 terms. This is a trinomial because it has 3 terms. So that multiplication will result in x cubed plus 4x squared plus 4x. Then I have to take the 2 and multiply by everything, and that would result in 2x squared plus 8x plus 8. Now from here, combine all my like terms and write the final answer in descending order, which means I put the highest exponent first and go from highest to lowest. So I'd have 6x squared, and I usually cross these out as I use them, then 12x, and then plus 8. Alright, I want you to complete E, F, G, and H for your assignment. I'm going to finish up by doing I and J. So for I, I'm going to distribute first the 4x squared, or there's my first and my outers. Then I'm going to distribute the negative 1. And then when I look to combine like terms, I notice that I don't have any, so that is complete. So for J, now I have 3 terms times 3 terms, so I'm actually going to have a total of 9 multiplications to complete. So this one is just a little long, a little tedious, but if you just take it step by step and make sure you write it neatly, you can get it done. So that would give me x to the 4th minus 4x cubed plus x squared. Now I'll distribute the 3x, so that'll give me 3x cubed minus 12x squared plus 3x. And now I'm going to distribute the negative 2, so I end up with a negative 2x squared plus 8x minus 2. Now notice I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. Remember I said I was going to have a total of basically 3 multiplications that I had to complete. So now when I combine all like terms, say I only have 1x to the 4th. I have 2 terms with x cubed. I'm going to use a different color here. So I have a negative 4 and a positive 3, which give me a 1x cubed. So for squareds, I have 1x squared minus 12 and minus 2. So that'll give me negative 11 minus 13x squared. Let's see, now I've left a 3x and 8x, which is plus 11x, and then a constant of minus 2. Okay, so k and l with a negative exponent, so we need to go back to our properties of negative exponents, and remember this is just the same thing, but this can be rewritten without a negative exponent as 1 over the quantity x plus 2 squared. And then we could just expand this, which would end up with 1 over x squared plus 4x plus 4. So that's just an equivalent form of that and that. So that's just 3 different ways to write that one expression. for one like this, then this would be the 2x minus 1 does not have a negative exponent, it's going to stay in the numerator. X plus 4 to the third. Now I have to expand this, so that means I need to multiply this, which I end up with, if I just multiply two of them together, I get x squared plus 8x plus 16. Now I need to distribute here, so I'm going to end up with x cubed plus 8x squared plus 64 plus 4x squared plus 32x plus 64. Hold on here, wait. X cubed. Hold on, go back. I messed up here. Hold on. Right, so let's go back. This was x cubed plus 8x squared plus 16x, then plus 4x squared plus 32x plus 64. So my final answer, my numerator will stay the same, all over hold on, I forgot to combine my like terms. So x cubed plus 12x squared plus 48x plus 64. Well, truthfully, the best form for this is this. You usually don't want to expand those denominators because you want it to look like this, so you can look at that and say that bottom is equal to 0 at -4, which means this ratio would be undefined when x is -4. Remember what we learned about domains. When it looks like this, we wouldn't be able to see that value of -4 making this ratio undefined. But since we are practicing expanding binomials, I went through and actually did cube that out. But this is better left like this, and the same for this one in K. This is better left in factored form. Alright, so you should finish as an assignment E, F, G, and H. Have those done for class tomorrow, and we'll practice some more of those in class as well.